Hello everyone, this is Riddhi Suteri, and today we are discussing this problem, that is carpooling. This is the problem statement, and let's see what all information it is given here and what all can we do with this. Obviously, I've read this description beforehand, so I'm not going to read it along with you. If you want to read the description, you can pause the video and you can read it, obviously. Now let me jump straight to the problem statement and let me explain what all the problem says and what all are we required to do here. The problem says that there is a cab driver and he is driving to east direction, and the constraint is that he cannot turn around or drive to west or any other direction. He has to travel in this straight line, and obviously he has a maximum limit of the passengers he can allow in his car. So suppose let's say for now it is n, and suppose he is at this position 0, let's call it, and he will be given with this array, this 2D array, wherein this array will contain these individual arrays, where the size of these arrays would be 3, and these individual array will contain 3 values. The first would be the number of passengers that are trying to board the car, the second their pickup location, and the third would be their drop location or their destination. Uh, all these values are in kilometers from the initial position of the car. So let's not take any kilometers right here. Let's just write down these value. So suppose for this, suppose for this we can say that 2 passengers are trying to board the car at stop 1 and they will go up till 5. Right. Similarly, the second array says that 3 passengers are trying to board the car at third stop, and they are and their drop location is at 7. Let's first of all complete this, and let's take another pen. Yeah. So 3 passengers are trying to do this thing. Now you can clearly see that we have a overlapping situation right here from third stop till fifth stop, wherein the total number of passengers sitting in the car would be 5, and the total number of allowed passengers in here was, here was 4, right? So obviously the total passengers sitting right in the third to fifth stop are greater than the capacity of the car, hence this trip is not possible. So in that cases we have to return false, and in the cases where these overlapping wala part doesn't happen, or if it happens the limit stays in the capacity of the car, we will return true in that case. Like in the second example you can see that the arrays are quite the same, but we have increased the capacity to 5, and the maximum capacity we can have during the trip was 5. So clearly 5 is not greater than, 5 is not greater than 5, so we will be returning true in that case. Right, so I hope I made the problem statement clear to you guys now. So let's see that how we can solve this problem and what all things that we have to do. So before that, what if we write down these steps that we have done here in a systematic order, and let's see if this information is anything beneficial for us or not. So what I've done is I've wrote these things beforehand because I don't want to make this video that much lengthy. So the first step you can see that so the first step you can see was to finding out the last drop location. You can see that we have made a timeline regarding the last drop location. So the first step was determining what was our drop location. Second step we created a timeline to track the trips, right? I mean, we have created this now ki suppose we are at 0 and we have suppose these steps, and there is the final 7th step. So second step is to create a timeline or a basic number line, you can say. Then what we did was we filled out these passengers according to the array. Filled out as in suppose what we did was ki suppose at step 1 2 3 2 passengers boarded, so we have filled out these values. Then at suppose at third से लेके 7th तक might be that 3 passengers boarded or 3 passengers were there in the car. So this whole step we have done in the third array. And at the last, what we did was we evaluated the situation. I mean, we traversed the array and we find out that if there is any overlapping position happening, or if at any stage the total number of passengers that are sitting in the car exceeds the limit of the capacity. I mean, exceeds the limit that we have as capacity. Or in that case, I have took n, right? So yeah, this all things that we have done uh, in order to solve this problem right till now. So what if I tell you that these all statements that we have done till here are exactly the solution for this problem? I mean, obviously we cannot write this algorithm, but we have to follow the program through this algorithm and we will be done with our code. So obviously, let me point out some other things according to the program. First of all, I mean, finding the last drop location would be very easy. How easy? I mean, let me give you a brief about that as well. So let's write this in here. Let's take Redman this time. So I've told you that there is an array that contains three array. I mean, yeah, three elements, and this can go up to any number of limits. So the 0th position right here denotes passengers. The first position of this array represents pick up. Let me write. Third is the drop thing. So if we if we have to find out the total number of passengers, we can clearly refers to the 0th index. For the pickup, we can refer to this, and for the drop, we can refer to this position, right? So I think I've made this thing clear to you. And if we have to find out the last drop location, as I was talking, so we can clearly traverse this array, and inside that we have to locate the maximum value possible in this second index of the individual arrays. I hope I'm making sense now. Don't worry if I'm not making much sense now. I will discuss this with the help of code as well in the later in the program. I mean later in the video. So please stick to the video. So after that, I mean, once we have got the last drop location of the cab, what we will do is we will create a timeline to track this trip. I mean, as we have done in the earlier in the video. So for that, obviously, we are not going to create a timeline or number line for that. We will be using arrays to do this work. How exactly using arrays, I will obviously tell you later in the video. Then we will be doing this adding and evacuating wala part that I will also be covering later. And then, I mean, it is very obvious that going by each index, we will check if the values containing or if passengers right at that spot exceeds the number of capacity or not. So accordingly, we will return true or false for that. So I hope things are very much clear till now. So let's discuss few other things, I mean, that I've left in here. First of all was key, what about array and how exactly array will solve our problem. So how array is that instead of keeping this timeline 0 1 2 3 and so on till 7, or in this case we will be making this array. I hope you are getting what I'm trying to say now. Yeah, so yeah, in the 0, let's write any random number, or let's write the number of passengers in the car at 0 spot. Add, suppose for this step, 2 passengers board from 2 and deboards at 3. So what we will be doing is exactly at second index we will write, or let's make it a larger value. Let's make that the deboards at 5. So at exactly at the second index we will write 2, or better to say that the existing value of 2 would be added by 2. I mean, the second index would be added by 2. Why? Because suppose maybe there might be a case that some passengers are already sitting into the car when we reach at the second spot. So what we have to do is we simply have to add 2 to that. And exactly at fifth index, what we have to do is, since 2 passengers deboards at the fifth index, so we will subtract 2 from the existing value of the 5. Obviously, initial values of all these variables will be 0. I mean, all these indexes would be 0. So this is how we are going to do this. Also, one more thing that I think you might have noticed is we have to create the array of drop location plus 1. I think it is pretty obvious that why we have to drop location +1, because we want this 7th index to be in the array as well. So if we make the array to be of drop locations, the last index would be 6. So that's why we have took drop location +1, and this will be our index in the array. So I hope this all is clear till now. After that, I think I've already made this adding and evacuating wala part clear with this part as well. And after that, it is very obvious that we will be traversing this array from the start itself, and we will check each index, and we will see that if value at any index exceeds capacity, we will simply return false. Else, after the traversal of this array, we will return true. So I think I've made all of these things clear by now. So let's jump straight into the code, and let's see what all I've coded and if it works or not. So here, let me take out a pen. Let's take this color. So there I have handled an edge case that suppose if there is no trip, or nobody wants to travel with the cab driver, or nobody wants to pull the car. So in that case, driver will anyways complete the trip from his initial position to his home, right? That was at X position. So in that case, we have to return true. Thereafter, I have, this is very basic step that I've done is I have found out the maximum drop location in here. I think this part is very much clear to you. I mean, this is what I've used as a for each loop in the Java, that is a syntax for each loop. So trips was the array, trip was a 2D array. What I've done is I have iterated over each array of this this trips array, this trips 2D array. So you can say that at every time, and I mean at each traversal, trip variable would contain this array, and we have to find out for its drop location. So we'll refer to its second index for the drop location, and we'll obviously have used the maximum variable mat.max to find out the existing drop location, to compare the existing drop location with this current drop location. So with that, we will get the drop location for that. After that, we have created a cumulative array, I mean a variable called cumulative array to store the array for that purpose. After that, I mean, it is very simple thing that we have done here is, now we have done is we have traversed the array, and we have marked values according to pickup and drop up. I mean the drop location. As I mentioned in the, let me show you that as well. So this thing, where it went, yeah, this thing that I was discussing, that at every stop where the passenger boards the car, we have to add the number of passenger to the existing point, and at every stop that passenger deboards the car, we have to subtract the count of the passenger leaving at that stop. So what I've done here is, yeah, I have okay, this is a kind of complex way of writing it, but yeah, let me help you down with this. What I've done is I have added this trip of 0. Why trip of 0? Because trip of 0 contains the again this pretty standard stuff for each loop. So again 0 because we have the number of passengers in the 0 spot, and we have added this to the existing value of trip of 0. Oh, sorry, trip of 1. Trip of 1 because this trip of 1 is the index in the cumulative array where the trip has to start for this customer, this passenger. Similarly, for this for his or her destination point, we have to reduce, or we have to subtract this count of passenger at that spot. So I think this is pretty much obvious by now. And after that, since once we have completed this much of part, this is very simple stuff. We have just traverse the cumulative array from the 0 till the drop location. We will also count the drop location as well, and we have maintained a passenger so far array, because we have to count the suppose at any step, suppose these are indices of the array. Suppose at any step, if we want to count if we want to judge if the seat overflows or not, we will have to get the total number of passengers sitting behind this person as well, behind this stop as well. So at for that, we have took passenger so far, and we will judge it by adding it with the current value of this stop as well, so for any incoming passengers. So first of all, we have calculated this value, and we have checked that if it exceeds the capacity or not. If this is the case, we will return the false. Else, we will update this seat or this stop with the total number of passengers so far plus incoming passengers at this stop as well. So once done that, I mean, if the loop runs very fine, I mean, if this statement is not encountered, that means that our trip is possible. So at the end of this loop, we will return true for that. So I think I've made this code clear as well. So let's run the code and let's see that if our code passes the basis test cases or not. Also, I've already tested this code against the final input as well, so it runs perfectly. Let me show you again. Yeah, so you can clearly see that it got accepted. So this was the video, and that's all for this video, right? And if you find this video helpful, you can like the video, and additionally you can consider subscribing to the channel as well, because that will give help for me. I mean, that will encourage me to do more such videos. And yeah, that's all. Thank you everyone.